Yeah, hi Sudhakar, how are you?
Yeah, I'm doing all right actually. Had a bad flu last night, and I think probably I will see a doctor today. But yeah, I tried my poked into this installing DNS GSM3.
GNS3, GNS3.
Yeah, GNS3. Yeah, I'm still trying to be comfortable with the terminology. So probably I'll try over the weekend, see if I'm able to successfully add, because I forgot that I have a Windows laptop which I bought like 1 year back and I haven't touched it. I'm not a Windows guy, but I installed VMware a long time back, and there are a couple of VMs with Linux on it. Uh,
Okay, okay,
so probably, and also they have a networking setup. With my minimum knowledge, I was able to bridge the networking with my ISP, with my with my local router.
okay.
Probably I will try and see if I can install there. Then I can install the GNS, right?
Yeah,
GNS3.
GNS3, yes.
GNS3, they have a new VM which I can install on my Mac.
Okay. Did you check with my backend team on the remote lab latency?
I haven't actually. I didn't get
Okay.
some time actually. Probably I will. I
Yeah,
will.
because we have students from all over the world and especially US as well.
Mhm.
Might be some people face the latency issue in case if there is any bandwidth or internet.
I normally do not have internet. I stream a lot of movies at 4K, so I don't think I have problems because I have almost like 1 GB of bandwidth. So
Oh,
yeah,
okay. So you once check with our technical people if
yeah,
you can fix anything.
yeah, yeah. Sure, I will do that.
Okay. So guys, we were on our lab. Let me share my screen. So let me just 2 minutes.
So the GNS3 has to be installed. The server part has to be installed on only Windows, right? It won't work on Mac.
That depends on your Mac chip. If you are running M1 chip, it will not work. The virtualization don't work on M1 chip.
Yeah, yeah. I don't. Yeah.
Yeah. So if it is a Intel, then you can have your VM Fusion,
Mhm.
over which you can have it on your laptop.
Okay.
Yeah. So that we need to check. Okay. So my backend people will let you know.
I know that mine is a new in the newer M1, so it won't work. I realized that actually.
Sir, I do have some questions about the lab you gave us in the previous class.
Yeah. Go ahead.
Sir, do we need to configure multiple IP for single router?
Yes, you can do that.
Like, sir, for interface Ethernet interface one, like 0/0, we need different IP, and for 0/1, we need different IP.
Yes.
Okay. So if we do need to configure the multiple IP, so why do we need?
Why do we need what? I didn't understand.
So because we can ping, if I'm on my virtualization, if I have three different types of operating system, so I can ping the three different machines with single IP.
Okay.
So then why do we need multiple IPs? I'm just confused about this.
Okay. Let me give you one example.
Okay.
So let's say you have a few sales team, marketing team, and let's say some engineering team. So these people are on a different subnet. Let's say we have a VLAN 10 for them, and the IP range is this network, and so on for the marketing people who are on a different subnet, and their IP address is let's say something this. And finally, the sales team who are on a different network, let's say VLAN 50, and they are running on 192.1.1.1/24. Now, all these three are different networks. Okay. And normally, as per normal layman's networking world, if you have this sort of configuration or this sort of IP segmenting, the sales cannot talk to the engineer team, and the engineering team cannot talk to the marketing team. Okay, might be the sales guy can talk to another sales computer. Let's say these are all PC computers or laptops. So you have one layer 2 Cisco switch with number of switch port, and if these are all connected to them, now they will not talk to each other. Sales may not talk to marketing, marketing may not talk to engineering. So there is a problem now. So to allow this communication, we need a layer 3 device sitting on the top. So we keep a router here. So router will have multiple switch port now, like gig port 0/1, 0/1, 0/2. So let's say 0/1 is responsible for your this engineering team. So let's say you will keep its gateway in the sense 192.168.1.1/24. So whatever engineering team, if they have to talk to sales team, these individual PC will send the request to the gateway, then gateway will know how to route the packet to reach another network. Okay, so all your gateways are configured on routers, L3 device. And that IP which you said on the interface is gonna be helpful to talk between one network to another network. You got that concern now? Why we use different IPs on an individual interface?
I have a question actually.
Yeah, go ahead.
I have, I mean, like, a basic understanding of this. So even though these are different subnets, they can connect to the same switch?
Yes, they can connect to the same switch because switch work on the VLAN concept. So I can have VLAN 10 configured here, I can have VLAN 20 configured here, and I can have VLAN 30 configured.
I had no idea about that actually. So maybe I will wait for you to explain that later in the later class. Yeah.
Yeah. So
I thought that
no.
different subnets have to go through the router first, and then.
No, not
Okay.
that. All your end device will be connected to layer 2 switch. Layer 2 switch will connect to the router over on the trunking port. So that there will be a trunk port here on this point.
Okay. Yeah. Okay. Then I will not get confused myself. I will wait for your explanation later.
Yeah. So Aditi, you're good with that, or you have some more doubt there?
No, sir. No, sir. Basically, I want to understand the multiple IPs, so I will understand with your example. Thank you, sir.
Yeah, but we will not go with multiple IP in production, because what happens in production is we have 10 teams, and if I give individual physical port like gig 0 for networking, gig 1 for marketing, eventually I need to buy a bigger box, and bigger box means in the sense more money. So what we normally do in the networking is we have something called as sub interface concept. So a physical interface like 0/0, it can be broken down into logical things like gig, 0/10, gig 0/20, gig 0/30. So here this resembles that the subnet VLAN. Let's say this was for marketing. This was for engineering team. This one was for the app development team. So one interface can be logically divided into multiple sub interface, and each sub interface then we will assign the IP addressing from each network.
So
Okay.
this concept is going to be covered later with the VLAN
Yeah,
stuff.
all this concept will come in your CCNA.
Sir, there is another way to ping each other with a single IP.
I didn't understand your questions. We are
Like,
picking it one to one only, right? Yeah.
sir, I'm saying that router one can router one can ping router 2 with the same IP that is ping with the routing 2.
1 second. See, you have router 1 and you
Huh.
want me to keep router 2. Okay,
Yeah,
then
yeah, yeah. Sir, and router 3.
on the same line.
Yes, sir. Sir, can I ping with the same IP to both of these? Router 1 to router 2 to router 3.
It depends. It depends, right? Say, for example, if you configured one IP here
Mm-hmm.
and you configured one IP here, then they only have visibility to themselves. Okay. They do not have visibility to this IP. R1 cannot ping R3. This cannot go this way until you have enabled the routing protocol. Getting that point? These are routing protocol. That is why which is important. They will pass on your information to the next devices.
Okay, sir. Okay, sir.
Okay. So
Okay.
you can have ping between this by default without any routing protocol. Either you can have ping between this two, R2 and R3. So you will have some IP configured here on some of the interface, and you will have one IP configured on this interface. So the communication will be between R1 and R2 and R2 and R3, but not R1 and R3. For that to communicate, you have to enable the routing protocol. Have you heard about the concept of RIP, OSPF, EIGRP, static routing? Have you heard anything so far? Or BGP, let's say, the routing protocols?
Yes, sir. I've used in the DOS. Like I've
Yeah, so
used.
this routing protocol has to be enabled so that R1 and R3 can talk to each other.
Okay, sir.
Okay.
So then, if this routing protocol is enabled, then R1 will gonna send the packet to R2. Then R2 will send the packet on the behalf of R1 to R3.
Correct. That is right. Okay.
Okay,
The
sir.
source and destination, R2 will be acting as the intermediate person to
Intermediate.
send the traffic and send response back the traffic to the initiator.
Okay, sir. Okay, sir. Thank you, sir.
All right, guys. So our lab on GNS is pending. Let's finish it. The creation of lab on GNS is quite simple. I'll take like 10 minutes to finish this on your lab. And since this is the last class of the week this week. So you on the weekend, you can spend some time on configuring on your side. So you also will learn how to create this nice topology. So this is something which we will create. Let me keep it somewhere here so that I can have a accessibility to that. And let me show you all the things that I can do as per the network diagram that I have. Okay. So I need 4 switches. So I'll tell you one more shortcut. Here in the GNS, if you want to bring 4 different nodes, you should have done like one at a time, right? But there is a shortcut to get all 4 switches in one single shot. You press shift button and drag it. What happens? It will ask me how many nodes I need. So I can say I need 4 nodes. See, and then I can just align them in an order. So this is where I will do all my L2 practice. For computers to initiate the ping traffic, let's keep this small PCs. Let me shift and bring it here. Let me keep, let's say 4 PC for now. So this is where I will configure VLAN 10, VLAN 20, 30, 40. I can show you sub-interface configuration, all that stuff. All right, so now, once this is done, I also had promised I'll show you some for firewall technology, but I don't see. Okay, there is Arista, which I don't need. Okay, I need firewall. Let me tell my backend so that they can put that. Okay, meanwhile, let me connect the cable. So computer user will be connected to the switch. So similar way, all different users, they will be connected to a switch. Let's say this is connected to this switch. And this is connected to this switch. Now, for some reason, this switch goes down. Now, what will happen to these people?
So they will not gonna talk to anyone, communicate.
Yeah. So what is the best practice? The best
You have to
practice.
connect the switch, both the switches together.
No,
I have no idea. I'm just throwing them some.
Okay. If this is going down, then PCs are left over, right? So what we can do is we can connect this PC to the switch. If this PC supports multi Ethernet, if the PC don't support multi Ethernet, then you might have the redundancy for this switch or the model. Okay. So for now, what I will do is I'll see if I can have multi cables assigned. So right now we don't have multi cables, but what I'm gonna do is I'll just go to the configure. All right, these machines here, they don't have two adapters. They have only one adapter. If I would have taken some other machines like Windows or something, then I could have added up two adapters. No issues. What I will do is I'll keep a redundancy on this to this. I'll say that switch 1 and switch are connected. And on the top, I'll connect all the rest of the switches. I'll have this to this. I'll also connect this to this. Tell me why I'm doing two cables from switch to switch.
To handle failures.
Yeah, one thing is failure and second thing is the load sharing. Okay, which is called
you can increase the bandwidth, right?
yes, ether channels, port channels. Nexus, we use the term VPC. So these are all your switching technologies over here. And also to practice, to make this look better, we can have some more ether channels configured so that I can ask you as an assignment to configure them. So 0/1, 0/1 to 0/1. So here in Cisco, there are two ether channel protocol. One is called LACP, Link Aggregation Control Protocol, and PAGP. PAGP is considered to be Cisco proprietary, whereas LACP is considered to be open source. That is why LACP is used widely in all the vendors because they are open source. LACP, link aggregation. You will see this LACP protocol, things like Nexus, or Palo Alto, F5, wherever, if you have this link aggregation concept where you bundle two links, you basically use this LACP in picture in that case. So to label anything in GNS, I can just make of this labels, and I can just reduce those so they fit properly on our lab. Okay, and then you can just style it. Border color, fill color. Let's say LACP. I give it as the violet color. Apply. Okay. To duplicate this, I can just duplicate it. Okay. So this bundle, this interface between those two switch, I'll make LACP configuration. So one I'll do myself. The second I'll give you guys to practice as a homework. And same way for second protocol, which is PAGP. Let's make another color combination. Let's say for PAGP, let's keep something in orange or something. Let's also duplicate this. So this is where I'll do the PAGP practice. So ether channel is done at this point. You will learn trunk, access layer, encapsulations, native VLANs, concept of all this you will learn. Spanning tree you will learn. So let me put all the text that we will be learning in the switching technology. The more I talk about these terms, you will grab them in an interesting way. If I just tell you theory in a class, you might know, you may not understand where these things are coming from. STP we will learn, which is spanning tree protocol. We will learn ether channel concepts. We will learn native VLAN. Definitely the bread and butters here are your VLANs, which are of type access VLANs and trunk VLANs. So trunk VLAN in the sense which can carry more number of VLAN, more than one. Access in the sense which carry only one VLAN. So these are some of the very hot topic from switching side. When we climb the ladder, the switch will be connected to firewall, which I told I'll get that. But for now, what I'll do is I'll just put some representation. Okay. So let's say there would be some firewall which should come later on. Or let me keep it aside for now. I'll once the AS has been loaded, I'll do that connection. For now, let me show you a switch will be connected to a router. And on another side, the same behavior. A switch will be connected to the router. So now I'm just asking it from very layman point of view. These are all VLAN concept. Okay. In the sense, you will configure some IP on the users. Let's say you say this is 192.168.1.100/24. Correct. You will send this. Then you will have another user who might be in a total separate network. He's from a guest network or he is from a marketing team. You have another person, might be he is a manager. So you have given him a very separate network to him. Okay, not 1.100. Let's say it is 55.100/24. And then let's say we have one more user who is from the marketing team or software coder, who is having 168.100/24. Okay. Now, why I'm giving that /24 across all of them, just to show you that this guy is a different network, this is a different network, this is a different network, and this is a different network. Okay. So let me write it down. What would be the range that PC1 can talk to? If he is having 1.200/24, he can at the most see only these people. Anything from .1 to 192.168.1.100. 255, but the first IP and the last IP are considered to be network identifier and the segment identifier. So we will eliminate those things. So the usable IPs are 1.2 to 254. And let's say this person has received .100, which is in between of this. So this guy can only see this people only, who might be from his own team. But now, if he has to talk to someone else, he has to send a file to someone else. He want to access another portal like attendance portal, payroll portal, which could be on a different network. So that time, all his frames has to be sent to the routers, and then router will do the inter-network connection. That is why we say routers are making a inter-network connections. So this network, this user's network is now interconnected with another network. Okay, so here we will see all the concept of VLANs, virtual local area network, and that virtual local area network is connected to routers where the gateways are configured. And since they maintain all the routing tables and all that thing, one router will know how to send or how to reach the next network via R2 or via R1. If the packet is outside, let's say the user is typing google.com. Now R2 will send to R1, R1 will send to another service provider, that service provider will send to another peer service provider, and it will go to Google and it will come back in the same direction. But if PC1 is communicating with PC4, that time R2 don't need to send to R1, because R2 will have its own routing table, which will say that send it to R3, and R3 will send it further bottom to R3 or R4. Okay, so this is a basic diagram as of now, and we will also keep some we will also keep some more protocols later on, which we can learn. So we can learn the HSRP concept, HSRP, VRRP, GBLB. So these are all your first hop redundancy protocol. HSRP is your CCNA topic, whereas VRRP and GBLP is your CCNP topic. So we will not touch them more. We will give focus on the HSRP. And apart from this, we need to learn the AAA servers. So let's bring some Radius server or TCAS server. Okay, we have a AAA. Install. Next. Finish. Okay. So this is my AAA server. Let me keep it somewhere here. Do you guys know what is AAA server?
No idea.
Okay.
No idea, sir.
Okay, let me tell you. Okay, let me tell you what is AAA server consists of. AAA server consists for two protocol. One is Radius and TCAS. The purpose of AAA is when I have 4 users, I can create the local users manually. I can say admin and I can say the password. But let's say if the number of users are increasing, I have 100 users, 200 users, 500 users. So I cannot create their login on each one of them. Correct? Because that's very tedious job. It's a manual job to create their credential on each of the networking devices. And if I don't do that, they may not have the access. The network engineer may not be having the access to router 1, router 2, router 3, and during the outage, he definitely cannot log in on those and do the troubleshooting, right? So what we do is we create all our user profiles on AAA servers.
So
So what?
user
Sorry,
user profiles like normal users or admin users?
anyone. You can create a normal admin, super admin, anyone. You can give them a specific role, and you can also create a properties like this user can do log into only this, or he can log into this. Correct. So all the logins will be here. Now, in very layman's language, when this user is trying to connect, let me use the marker. Let's say when this user is trying to access this, what happens is your switching and routing will take the packets to this, but router is connected to a AAA server. So this router will send the backend traffic to AAA server to check whether this user is legitimate user with the right username or password, or he's some spoofed person, not a legitimate person. Now AAA, as I told, will have all the user profile. AAA will say yes, this is the right person, which who has this access reachability, and he is having the right username and password triggered at the first place. So that return traffic will go back to router. Now router will allow the connection. Now this PC can access router and do whatever configuration or troubleshooting that he's supposed to do. Okay, so AAA is like user profile. User authentication profiles are created on the backend.
So for example, an user wants to access a machine in a different data center, so his profiles should be created in the sorry, what is this server? Sorry, Discover.
AAA.
Yeah.
Yes. So we earlier had something called Cisco ACS. Have you heard about Cisco ICE?
No.
Okay, Cisco ICE is one of such product now, which lets user profiling, etc. Or we can go with any small Linux package too, which can create a basic user profiling for us.
I thought only from sysadmin point of view, I thought just the profile has to be created in Kerberos. So there is another layer of user authentication in AAA servers. Is that right?
Yes, you can create a normal username. Plus, you can also create a two-way authentication process as well.
Okay.
Okay, like SAML, Google Duo, RSA token, all these things you can allow it. That is why the ACS were having some delimitations which could not be fixed. So that product got end of life, and Cisco launched another product called as Cisco ICE, which can do a lot of things apart from profiling, like wired profiling, wireless profiling, guest profiling. A lot of things it can do, DNAC integrations. Okay, so from our lab point of view, for now we have a few of these things. As and then we talk about the protocol, we will discuss about it. Now let me do some theory for now. Let me cover up the OSI layer so that you understand the flow in the networking. See, actually, to explain the network flow, they 20 years back or 15 years back, 20 years back, there used to be a problem to give a knowledge transfer to a very layman to explain how networking happens, what happens in networking. So that's why the US defense, they launched some model called as TCP IP model in the year 1970s. So as per this, there were only 4 layers. There were only 4 layers. Like let's say application layer. Then we had something called transport layer, network layer, and let's say the data and the physical layer. 1, 2, 3, and 4. So application layers are all your front end facing, like HTML or the DNS, DHCP. So all these are considered to be, okay, not DHCP, sorry, HTTP. I mean to say HTTP here. So examples for application layers are HTTP, DNS. And for transport layer, you had TCP and UDP. For network layer, you had the layer 3, like IP addressing or IPv4. And data and physical was your layer 2, and all your physical cabling and the layer 2 technology like frame relay or Ethernet, ATMs, low end technology, which are now actually end of the life as well. So this used to be the layers that we had in 1970s. Later on, there was another logical model was developed, which was referred as OSI, Open System Interconnection. So as per this model, we just elaborated whatever we had previously to 7 layers, total 7 layers. So first being application, presentation, session, transport, network, data, and physical. Okay. So here, application being on the topmost, which is nothing but like HTTP or DNS, whatever protocol they are called as layer 7 protocols. Okay, so let's say you have a machine. So on a machine, you might use some browsers. So those browsers are basically in the backend have all HTTP protocols that's been packaged and sent to the bottom of the OSI layer. So whatever is being packaged, they goes to presentation. Presentation is nothing but where you have the encoders. So presentation layer is nothing but it will prepare the topmost layer in a presentable way, because you are sending this over on the computer terminology like 0 and 1 bits. So on the other side, when it reach, they get extracted, and once they get extracted, the presentation layer should say that this was a JPEG, this was a MP4, this was a PNG. So this just do the work of presenting, like encoders, decoders, and then it will add its header and send it to sessions. So sessions are created at this point. Basically, sessions are to have a reliability. They try to keep connection oriented, in the sense they will try to have a sessions created so that let's say for an example, I have a browser and the browser might have 3 tabs. So one tab was for a WhatsApp, one for a Facebook, one for Outlook. So it should create a session saying that if the session was initiated by WhatsApp tab. So when you get back the response, it should go to the same session. Okay. So that will take care by the session layer. So session layer will add its header, will send to transport. Now what transport does it? Transports are your UDP and TCP packet. They check the reliability, UDP and TCP. So what transport will do is they will see the reliability. The packets coming to us is in a UDP packaged header or TCP packaged header. If it see that it's a UDP, then it will spare very less uh, resource. It will spare less utilization on sending any traffic. Or if it is a TCP, then it will have a different process. It will try to make a three-way handshake before it send it to the next person on the other side. So transport layer will also check whether it's a reliable thing, whether if the three-way handshake is not happening, then the TCP or data will not get triggered. So that is acting as transport channel. It will add its header and send to the network layer. Now network layer is where you have IP addressing. So you should think it in this way, that let's say R1 needs to know to reach R4, what are the best path? Should I go with this path or should I take this path? So routers are considered as a network component which sits in the network layer. And router is also called as a layer 3 device, layer 3 OSI device. Once that header is been added, so we call this network as packet. So once the packet are sent to data, which is now called as frame, what data do is data do some sort of error correction checks, which is also called CRC checks. It will also check the MAC address. The concept of MAC address comes in the layer 2. It's a layer 2 OSI layer. Okay. CRC in the sense when you're sending some packet to the data, it will see that whether there is any data lost while doing that. If it has to package it up, it will also check the hexadecimal with related to that. CRC are basically some sort of hexadecimal. If that hexadecimal don't match, that layer is gonna discard that particular frame. It's gonna say that this has been tempered or this has been broken while you're transmitted source to destination. So resend it. So now that person, the router has to resend it from the other side. So it is basically to see error correction, whether it's you're receiving the right frame or it's been corrupted. And physical is nothing but all your physical layers, like your cable or your wireless technology, if you're using Wi-Fi, whatever. So this is from one side or one point of view. I can say that it is from the source point. You had your machine, you had your laptop, you were browsing http.google.com, which was application layer, which in the backend represented or it converted into presentable format. It created a session. So all the first three happens within your laptop itself. And once that has been packaged, the packets are going out, then it goes to your internet, home internet, or if you're in your enterprise or something, then you will send it to the network wherever the gateway it is. So that gateway will check where is the next person located. So before sending that, what it will do, it will also check into the data headers. It will see the exact location to reach that, because in the network the IP address are usually called the logical addressing. Okay, logical addressing. But in the data OSI layer, which is nothing but layer 2, they are basically nothing but the physical address of the device. This is logical. This can change if the person has logged out and has not come back or connected to the network for, let's say, 6 days. That IP can go to another person. It's called lease expiry, etc. So that IP can go. So these IPs are changeable. They are not a fixed thing. But physical address, which is nothing but your MAC address, they are binded to your machine, which will never change. Okay. So the network, though it knows how to reach, but network will then send to data plane, data OSI layer to find the actual location of that particular person. It's like, for example, you have a postal courier. Okay, so usually the pin codes are referred. The pin code will give some sort of hint to the postal person to reach to your area. Okay, might be this is some code on your postal. So the postman is here, but in the this postal there are a lot of houses. So how would he know which house to be delivered? So there is where the door number comes. Let's say a door number like 124, right? So he will refer the pin code to be this and door number to be 124, so that the parcel come exactly to you. So similar way, the pin code is nothing but your IPv4 addressing, which will tell the guy how to reach there in a shortest way. But MAC address is what which will tell that packet whom to deliver. Okay, so that is why network will send to data, data will send to physical. Physical is nothing but your cables and wireless connection between two different nodes. And on the other side, they start getting decapsulation. I'll tell you the process in a to and fro manner. Let's say this is source and this is destination. You are sending an email. Let's say you're using gmail.com or something, right? So you are making use gmail.com on your machine. The same gmail.com, your friend would be also using on his side. That is how he get to know that you have sent some important communication over email to him. So from the source side, he might be having his laptop connected to internet. He opens up gmail.com. He start preparing his content body, right? And then he send, he click on the send button. Now in this moment, those graphical or those text, etc., they get carried upon using something called HTTP protocol in the backend. Okay, which is an application layer. Now this HTTP will needs to be encoded so that see, because the source can do anything. He might be browsing, so HTTP. What if he was trying to send a JPEG pictures, or he was trying to send a MP4 or whatever things what he was doing? So it has to be presented in such a way that the receiver can understand it. So presentation layer, where basically the encoders and packaging and all that thing happen. Later on, a session get created. As I told you one example, he might be doing multiple tasks on his machine. He might be composing an email. He might be playing a game. He might be making some bank transaction. He might be having a WhatsApp installed. So these are all individual sessions now. These are individual session. So now let's say Gmail was initiated. So a session for Gmail tab is created. So all the first three happens on your own machine. Let's say on your own machine that is happening. And then after the sessions are created, you will send it to transport layer, which is nothing but whether it's a TCP or it's UDP, depending upon what protocol you are utilizing in the application layer. If you're using a TCP, then it will be packaged with TCP header, because HTTP are considered to be more critical packets and more important packets. So you need to send those HTTP packet once you have gone through the three-way handshake. Now let's say not all traffics are, or not all applications are that useful. Some application without a three-way as well can travel in a better way. Like let's say for voice or DNS or all these things, you don't use TCP because they will consume more utilization. Plus we can let them take the UDP packets. So let's say if I'm making some DNS query, or I was making some video conference or something, my transport layer will bind UDP to that, which are non-reliable packets. I can see some buffer happening, but still that is fine. I'm not getting disconnected. I might lose the quality of my video, but I can still hear the voice from the participant or something, right? So some traffic or some application get classified as UDP. Now in the next step, what this transport layer does it, transport layer needs to know how the segments can reach this guy on the destination. So it will send it to the network layer. Network layer, which works on concept of IP addressing, it will see its routing table. It will know that to reach this, let's say, US region, I need to go via so and so and so path. So that's also done from the networking side. Now, you do not know where exactly in US, because in US there could be a lot of users, lot of IPs, lot of users, lot of machines. Which exact machine is that you are trying to send this? So that is decided in the data layer. So data layer along with MAC address also check the CRC and all other error corrections. Then it will send to the physical layer. Physical layers are all your cables and wireless connectivity. Cable and wireless, let's say your exit point. Here, let's say if this is a cable, so your analog signal, the bits 0 and 1, you know that computer always have 0 and 1 as a communication, right? So 0, 1, 0, 1, these are converted. All your different traffic, different types of application started with application. Now they are transmitted in 0, 1 bits. Now on the other side, the same process repeats. Now you are decoding them. So it starts with physical layer. Now let's say this is the first point, physical layer. Physical layer will send it to the data layer. Data layer will remove the header that was sent to it. It will remove the header. It will try to see the content. Now it knows that it needs to send to the so and so network. So network header is removed, which was initially added upon. Then it will send to the transport layer. Then it will send to the session layer. Then it will send back to the presentation, and the presentation will once again revert back to whatever the look and feel of that should be. If it is an email, then you will see an email notified here that one new email received. When you open it, you will see the way it should work. If it was a WhatsApp message, you will receive that WhatsApp. Okay, so a lot of things happen apart from the basic things. There are concept of TCP windowing, TCP sliding. These are all advanced levels which comes in the TCP concept. And in the network layer, you will see the IP addressing. So you definitely need to learn the different protocols like routing protocols, right? And here you will see the MAC address concept. So these are 48 bytes of MAC address. Okay, so this is how it's a logical concept. Okay, it's not something that defined to be a practical or something. It's just a logical thing to explain the network behavior. So if someone asks you how this communication happen between one computer to other computer, let's say 192.168.1.1 is talking to 171.1.1.1. So what is happening intermediately, right? Might be this guy is using a Java program, whereas this person is using some Python. Might be this guy is using a web browser. Might be this guy is using a client. So all the computer levels of things will be covered in your application layer itself, which consists of application, presentation, and session. Later on, the network layer will be decided by the routers that you have in your site as well as the destination site. Okay, so you will decide, the router will decide how to reach, and also before it send it out, you know that there will be some switches, etc., which are connected to it, which determines the physical or the actual location of these users, right? So on this switch, or let's say on the switch, you might have different types of users, but the data will only go to the right person, not to all of them. So the switch maintain all your MAC address table. Okay, so this way the traffic from one side to other side reaches. So this is a logical way of explaining the network flow. So let me put some protocols for application layer. You have HTTP, FTP, file transfer protocol, simple mail transfer protocol, domain name system, post office protocol. Again, this is relevant to your mail messengers. This is file transfer. This is your domain name queries. This is your web traffic. For presentation layer, it's encoded format, encoding algorithm, encryptions, and compressing the data. Okay, so for presentation layer, you have encoders, you have UTF encoder, you have ASCII encoders, encryption, different algorithms for encryption and compression of the data. Also remember, this path will have certain maximum capability to send the data traffic. Okay, say for example, this application on this side is downloading a 10 GB of file. So not entire 10 GB of file get downloaded in single shot. They go packet by packet. Okay, so once they have a session created between source and destination, I told the concept in the transport layer. There is concept of TCP windowing and TCP sliding. Let's say you have a path which can support 1024 bytes, but you are actually transmitting 10 GB, which is way beyond this small unit. Now, your data, let's say if this is a data 10 GB, this get broken in various crunches, very small pieces. Okay, like a small piece, see, this way, they get broken up. Now the small chunk, they might have a size capability of, let's say, 900 bytes. Okay, so I say 900 bytes, but I say that you can allow 1024. So there is some more things that you could have added up, right? Some more data, but you can't do that because the headers will get added up in every layer. So when you're sending it from one layer to another layer, there will be some bytes of header which keep on getting added up. So when you see the packet on this layers, your packet would look like something like this. You will have data. This is your data. If it is a HTTP, DNS, SMTP, whatever it is, it's a data which is of, let's say, 700 to 800 bytes. Rest, you will have a headers here. As I told you, when it is received on the other side, that person needs to know which IP, what MAC address, what encryption. So each headers is added. So let's say here presentation was added. Here transport was added, here network was added, here data layer was added. So basically you have to keep some rooms for the header also. So remaining 100 to 200 bytes are used for the header itself. And data is 700 to 800. That's why a big packet, data packet, needs to be broken in multiple pieces let's say you have each one of 900 bytes. So you need at least, let's say, 200 packets to be transmitted to just push this 10 GB of file. And each such small packet will have the headers. So basically your packets, they look with headers. Okay, you will have the data. You will have the data, plus you will have all the information carried upon. What is the router, which router, what's the physical MAC address associated, what is the encryption algorithm, etc. So that's all carried upon with each one of the small chunks. Okay, might be one small packet is going in this direction. Might be you have another packet piled up, which is taking in a different direction. You have a third packet which is going in this direction. Now, for some reason, that third packet is lost. Why it is lost? Let's say some latency issue, some packet flow in that particular direction is not good, some cable cuts, whatever it is. While receiving, they only received 99 chunks. You sent 100, but it received only 99. So this is where the concept of TCP comes into picture. Okay, if you're making use of transport layer, which is a TCP, TCP will make sure that there is a three-way handshake for every such small packet. For this also, it should have done a three-way handshake. If the three-way handshake don't happen, it will not send the packet on that path itself. It will now reuse the same path which it might have used previously. So that is why TCPs are considered reliable. You send 100, the other person must receive 100. Like your banking transactions, your critical files that you are accessing, whichever comes with HTTP, HTTPS, or whichever is a TCP packet, they will make sure before sending the data that there is a hello and response coming from. It's called SYNAC and acknowledge packet. Once, see what happens, it will send one SYN packet, a small size packet. The other person has to reply back with SYNAC. Now this guy will send back a acknowledge packet that yes, I have received your SYNAC, I'm sending my acknowledge. And after that, it will send one small piece of such chunk over on that path. So while you receive all 100 chunk. Your 100 chunk will now be recompiled to make a bigger file which is in a presentable mode. So that is why when it climbed the ladder, session, presentable, and application, the other person will see as similar as what it is supposed to be. He will not see the things in small chunks or something. So you understood this flow?
Yes, I have a question, follow-up question on this.
Yeah.
So what happens intermediary, like the packets are flowing through different routers, and are they going to be examined by the routers? Like, will they be examining the packet where the next hop is?
See, when it reaches the intermediate router, the OSI will not reoccur. Okay. So let's say if
Okay.
the packet which just left from this machine reaches to this router, only the routing table is consulted. Routing table. And it will forward it to the next person. So he will also do the routing table. When it reaches the destination, so that time the decapsulation happens. Removing of headers will happen.
Got it. Thank you.
So Aditya, Bharat, you guys have any question? Because we will wind up here. It's 1 hour. And we will meet on Monday.
Sir, I guess in the last slide, you have written the 48 bytes. Bytes.
Yeah.
I guess it will be the 48 bits.
Okay, 1 second. Yeah, it is 32-bit and 48-bit, right?
Yeah.
Yeah, it's 48-bit here. Okay, and these IP are 32-bit. So what is the correlation between bit and bytes?
Sir, I guess 1 byte is equals to 8 bit.
Yes. So 1 byte equals to 8 bits. So when I have a 32 bit of IP addressing, so how many bytes of it should be in
4 bytes.
Yeah, so it will be 4 bytes. Similarly, when I say 48 bit of MAC address,
6.
yeah, so it will be 6 bytes. Okay, so we'll end for OSI today. In the next class, I'll take you with the IP classes. Let's finish that IP classes, and let me show you a subnet for now, so that you can understand the network. So let me show you a class C subnetting, and I'll show you the different IP classes. Okay, the ranges of each classes. So good for now.
Yes, sir. Thank you, sir.
Bharat and Sudhakar, any question?
No, actually, it's good.
Okay, all right, okay. Yeah, take care, guys. Recording is
Yeah, I
visible.
have few questions. I'm going to side chat you actually. Okay, thank you.
Oh, okay, yeah, sure. Okay, thank you.